Hello and welcome to DockerCon 2022. My name is Maysam. I'll be your host today for a talk about running an AWS stack on your local machine. I have been working as a software engineer for the past 5 years, and in the last 6 months or so, I've been working inside licenseware. You can reach me out if you like via my LinkedIn, and there are all the other links related to me if you're interested. And without further ado, let's get down to business. So, for the tools and requirements that you are going to need to run this stack, first of all, and the most important one is that you are going to need Docker Compose version 2. I have tried on Docker Compose version 1. It wasn't, the desired and expected behavior, basically. And you're going to need these entries in your host file. I mean, you can change it if you like, but this has been configured inside the GitHub repository, and you can, fork it, clone it if you like, change it, tweak it, and play around with it. So yeah, this is inside my host file, and I'll be able to access the stack using these addresses. Preferably use VS Code, but any IDE will work, and also optionally use Docker Desktop. I have my environment created here. You can use creates, get started. A local repo would do. I've used this folder. I can click open, and this will create another stack for me, which well, I already have one, but yeah, it's always good to show you how it's done. So yeah, there you go. And without any further talk, the first part of this discussion is about development. So make everything configurable, either the port, the URL prefix, the v1, v2, anything that can be configured, the database connection string, the Redis, host, machine, port, password, anything. So basically, if you have a high-paying customer that needs on-premise deployment, your application should not need to change inside the source code for another kind of deployments, basically, if you want to just deploy another port. So that's just configuration. It's a violation of 12-factor app if you need to change your source code for just a port. So make everything configurable, and you can also see that inside these stack right here as well. So if you go to app, you can see this, for example, port, debug, app prefix, everything is just configurable and can be configured, with different configuration and in a different environment, dev, staging, production, and everything. So this is specifically tied to Python, sort your requirements file, because it makes pip package management processing much more optimized. If you come down to the service tree, which has the longest requirements, you can see that it's all sorted alphabetically, and it makes the pip package management processing much more optimized. This is not related to Docker, but always a good practice to go for tests, TDD, or otherwise just a good reminder. Always do that. It makes your life a lot easier. So, getting to the more important part of this talk, Dockerfile. Place your most static lines at the top. The static lines are the lines that are not changing quite often, and it enables you to use Docker layer caching. So, for example, you can see here that in the top, I received the packages from requirements file inside the container. I basically download them inside the container. And if further on in 1 week, let's say, I do not have internet connection, I can use the caching layer, if I haven't already removed the caches, to basically just install the libraries on the local machine without any internet connection. And this is powerful because caching enables you to just build image faster, and you don't have to wait for a lot of time. And it makes operations a lot easier. Use multi-stage builds. This goes for either if you want to deploy on production. For example, I have to open telemetry on production, but I don't need it on dev or test or staging. So I'm able to do that. And also you can use this concept for your caching layer, and basically just doing that. I mean, installing from local just the libraries that you have previously downloaded from another stage, from a previous stage, is pretty powerful when you don't have an internet connection, but you need your application to work and run and to be able to change your code. So I usually put my default stage in the last, but you can always specify which stage you would like to have, basically in build target or on Docker build target, something like this. This also works, so it's pretty powerful. And go for the smallest possible base image. So, for example, if you can go for Alpine, go for it. I mean, in my application, I don't do anything very special, and it doesn't need any, C libraries to be compiled, anything. So basically, I was able to build a base image from Alpine, and if you can see my images from here, you can see that the size of the image is quite, low in terms of you have seen 1 GB of images elsewhere. So having a small, image enables you to just transfer the lowest amount of possible bytes to the deployment machine, and it makes deployment much faster. So you want that basically faster, better, and everything. So it's pretty cool. So go for something light, either Alpine, Slimbuster, or I'm basically talking about Python here, but other languages also have this concept of having the base and minimal amounts of libraries installed on the image, and so you don't have to have everything. And it's also a good best practice for security as well if a library is in any way compromised. To the last and most important part of this talk is about Docker Compose. So first and foremost important part is that upgrade your Docker Compose to version 2. So you can check here inside their GitHub repository, the release page. They have actually compiled for every environment, and you can just download it and use it in your application and your machine. So I have already done that, but and you can see it from here. This is version 2, but how it's done is just basically using a curl command and just giving it a link, and then using chmod plus X, and finally just moving the file into your user local or user local bin. That's all it takes. So it's pretty straightforward. I don't have to explain it too much to take too much of your time. So most of this talk is about these parts. Actually, the most important part of this talk is about uh, let's begin. So put related services into the same network. The services that need to talk to each other. Your application, if it needs to talk to the database, the caching, the Redis, Memcache, whatever, just put them on the same network. But don't put everything on the same network. We at Licenseware have many services, and they don't always have to talk to each other necessarily. So we don't jumble them and mix them into the same network. This is good for security, maintainability, operations, visibility, and there are a lot of advantages, the countless advantages that you should consider. Put only this related services in the same network, and otherwise just don't do that. And the other thing that you should keep in mind is that if you do not specify any network, it will be a network with a default at the end, and they will basically put in the same network. It's something like a default. So for example, in my service tree, I have this Docker Compose here, and they don't have any network defined here. So what happens is that if I come and create Docker Compose up in service tree, there will be a network default created for them. And yeah, they are all in the same network. And it is pretty cool for me because they need to talk to each other. the migration, the web app, they need to talk to each other, so they need to be in the same network. But if I come to the entire platform, I mean, all the services all in one place, you can see that everyone has its own compose file, and they are only on the same network if they really have to talk to each other. Like Postgres has this network defined here, and my service tree can use that Postgres network to talk to the database, to run the migrations, and to run the web app, basically. So, with that out of the way, uh, you should also consider putting your services, the related services, in the same and different ones in another compose file. You can also see that happening here in the entire platform. I have all the stacks. We have three services here, and well, this is just an example, but you get the idea of how a real world application might probably be. So, for example, my service tree has two jobs actually. One long running one is a web service which is receiving traffic from an internet connection and responding back. It's a sample CRUD application. If you can probably check out the source codes, not very much complicated. And there's another migrate bound, which is just running the migration and exiting with status code 0. So separating them out, even on the related services kind of type, it's pretty powerful in terms that you get to see which services has actually exited with the status code 0, and depending on that, actually, let's say, service to run and exit 0, and then our web application is running. So if my tables and databases are not created successfully, I cannot run my web applications. So this really depends on it. And yeah, put all these related services in the same compose file, but put and separate out the applications that shouldn't be mixed together. The migration, all the backup, maybe you do some cron job here and there. They don't need to be mixed in your web application or your main application, the long running application, because otherwise it confuses the operations team. And well, this is actually not very good idea to just mix everything together. Your visibility will be decreased over how the platform is actually behaving. And yeah, that's actually the next point, to separate the one-off tasks, the migrations, the backups. I don't know, anything that doesn't have to be in your main application should not be there, basically. So the next point, use DockerCon, use compose file environment variable. So there is this pattern of father, or let's say parent or child environment, and we'll get there in the next point after this as well. So I'm gonna explain it here. The fact that you can use this parent-child behavior to replace your environment variables. So yeah, use compose file. Basically, you define different compose files in different Docker Compose YAML files, and in order for the Docker Compose binary to be able to detect them, all you need to do is just define, put them in the compose file environment variable with a colon separated, character. And the order really here matters, because you see, for example, traffic is the gateway here. The Redis is the caching, and the Postgres is the database. And they are defining some network. If you check the compose file, you can see the network in Postgres. You can check the Redis, the network, and also the traffic is also having this gateway here. So they will be able to communicate if they have that network, right? I mean, my service tree here needs that gateway and Postgres to be available. Therefore, it is defining them as external here. So if it is not defined elsewhere, Docker Compose will most likely complain about it. So that's why the order here matters, actually. The definitions has to be last. And for example, if it is defining a network, it should be last. If this one, yeah, the last. Also, You get the idea. So definitions should be the last files in composefile. And yeah, I'm gonna explain the EMV substitution first. This parent-child thing. You see, I have this Postgres user password and DB defined here. And for example, in my EMV for Postgres, which is using here, um, I don't even need to define them again. I just need to just specify the key here, and it will be able to pick it up by compose. If you check here, so inside the Postgres, you can see that it has already been populated with the right values. And also elsewhere in my SVC3, I'm using the same concept, like SVC3 needs that values, Postgres user, password, and DB. It's just an EMV substitution. It's pretty powerful. So you can see SVC3 here, and it has already been substituted with the right values. So this is pretty powerful. You just need to change one place and it will be reflected over the other parts. So this is pretty the cool part. I have two services, one using this part and the other one using the other method, which we'll get in a moment. So you see, in my service tree, I need to be able to route the traffic outside the container, resolved on my local machine, and then back into the another container. I'm able to hack that with this technique using extra host. This line right here is telling that every traffic going to this address has to be resolved in here, and this address is basically the IP address of gateway of Docker bridge network. So it's just adding one line to etc resolve conf, and therefore it's able to sending the traffic in my machine without going to the internet. It will be resolved back into the another container. This is one cool hack that you can use basically. Optionally use health check. There are two methods. One is for Dockerfile. The syntax is pretty clear. You can check them and check the reference. And the other would be to go for Docker Compose version. You can go for either way that you like, and it's basically a good visibility over your system on your platform if you want to see your application is up and running. And it's also good for your load balancer basically, because you also will be able to see if the traffic can be routed to your service or not. I mean, load balancer uses that technique to see if it can forward traffic. Use compose project name. This is not necessary, but you can you can have the same compose files in the same directory but with different compose project names. So you see here, if I go top of the file, the name is DockerCon, and this DockerCon is coming from here. I can change this name, bring up another stack, and it will be still all good. And it's just another stack and another set of containers basically. It's pretty powerful. With a new set of volume, with a new set of networks, you can have different stacks running with the same containers but with different names. And that's if you want to have different, let's say, deployments of your application with different configuration. So that's all about the theory part, and let's just check the entire platform here. This is all this applications, all the services. There are three services talking to each other, and you can check the design here. The first service doesn't do anything. The second is just asking the third service and caching the results, and it's the invalidation of cache is nothing too special actually. It's just TTL, just after 10 minutes remove the entry. And the third service is just a sample CRUD application, like our everyday job. So let's just bring the stack up. I think it's already up, but let's just make sure. PS. Okay, so they are not. We should be able to do this. And the health check that I was talking about. So in your day-to-day job, you might find it pretty useful to see your services are up and running, and the load balancer can also benefit from that. and route traffic to your service if they are healthy. So they are both healthy, and now we should be able to first of all go to traffic to see the services are well, the rules are defined. This is actually the my gateway, the reverse proxy. So you see, these addresses will be resolved on my local machine without going to the internet, only because of the fact that I am able to, well, you see, I am able to see them here, etc host. I have hacked my host file so that these addresses do not go to internet. They will be resolved on my machine. So defining these here is just making my computer look like a router, let's say. So this is the first service. It's able to communicate with that. This is the second one. It's also able to communicate. And this is only on the entire platform section. So if you run the services one by one, you will not see this address. So this is also working. You can see that the host name are different. These are different host names. So yeah, so different services. And I'm also going to be able to go to docs here, create some item. This is just a boilerplate. I didn't do much about it. It's just creating some schema and everything. So there are 2 items, 6 items, all right. And in here, in my second service, I'm able to see this part with, this is just gonna go to, this will, the traffic actually will come out of container, be resolved in my local machine and back to the other container. This is V2 actually. And there's also a V3 which does not do that. So you see, this was happening and the traffic came outside the container in my local machine back to another container. You can also check that here. Compose log/ft. So SVC3 and SVC2. This is all I need right now. So I'm gonna go for another one because it has already been cached. So you can see the address is quite interesting. This is the address of SVC3 was able to receive the traffic because SVC2 has sent that traffic from the bridge. So you see, this is the address of Docker Network bridge. So I'm gonna go for another method here, and that would be to communicate between my services without coming to resolve on my local machine. And so the first method was using this extra host and going to the gateway and resolving on my machine using the etc hosts. The second method is putting them in the same network, like you see here, and the traffic doesn't come out. They are just going to be communicating inside the Docker network. It doesn't even come out to my machine. It's just they're communicating with each other inside the network that has been defined for them. So this is the, I'm gonna copy this, use V3 for this, and we should be able to see the logs here. There you go. So this is quite interesting. So you can see that they were able to communicate with each other by the address of themselves. The SVC3 received from 0.5. Another approach was, if you check here, 0.5, not 0.5, but you see 0.2. So this is quite interesting. The networking and everything is just quite interesting. You get to see that the traffic can come out, go to the container, and also be communicating with each other inside the network, basically. So that was it. That was all it is. And the container, the source code is already on the GitHub, so you will be able to access it using this link. The design, the README is everything complete. You can also reach out to me if you have any other questions. I hope you find this talk useful and you can use it in your local machine. Have fun with it. This is basically what we do in Licenseware to have the dev and production in our machine to be able to change them and see the reflection of that change to see if we have broken anything, if that change is working all right and anything. So yeah, this is like a stack manager, basically the name that we use on LicenseWare to have the stack on our local machine, change it and reflect it, and then if successful, just push it to the default branch. Uh, I hope you find this talk very useful and interesting, and I hope you find the rest of the talks of DockerCon pretty useful. And thank you very much for your time, and I hope you find it useful. Take care, stay safe, and goodbye.